The ocean is often perceived as a symbol of calm, an endless blue horizon breathing in steady rhythm with the moon. For generations, humanity has trusted this rhythm, building cities along coastlines, trading across seas, and finding comfort in the predictable rise and fall of the tides. Yet beneath this familiar surface lies a restless world, shaped by immense forces moving far beyond human sight. Deep below the ocean floor, the earth is never still. Massive tectonic plates grind against one another in slow motion, accumulating pressure over centuries. When that pressure is suddenly released, the seafloor shifts in a matter of seconds, and the ocean listens. A tsunami does not announce itself with wind or rain. It begins in silence. Far from shore, the sea may appear unchanged. No towering waves, no visible threat. Ships pass overhead, unaware that beneath them, an entire ocean basin has been set into motion. Energy travels outward in all directions, racing across the deep at incredible speed, carrying the potential to reshape coastlines and lives. As the wave approaches land, the ocean behaves strangely. The water may pull back, exposing the seafloor in an eerie stillness. Fish writhe on bare sand. Harbors drain. For those who do not recognize the warning, curiosity replaces fear, just moments before devastation arrives. When the tsunami finally strikes, it is not a single wave, but a relentless surge of water, carrying debris, buildings, and memories with unstoppable force. In minutes, landscapes are transformed. In hours, history is rewritten. This is the story of the tsunami, a phenomenon born in the depths of the earth, silent in its journey and overwhelming in its arrival. A reminder that the ocean, though beautiful, is never truly asleep. A tsunami is a powerful series of ocean waves caused by the sudden displacement of a large volume of water. Unlike ordinary waves generated by wind at the ocean's surface, tsunamis involve the movement of water from the surface all the way down to the seafloor. This fundamental difference is what gives tsunamis their extraordinary energy and destructive potential. The term tsunami comes from Japanese, meaning harbor wave. Japanese coastal communities observed long ago that the sea could appear calm offshore, while devastating surges destroyed harbors without warning. Modern science has since revealed why. When a major geological event, most commonly an underwater earthquake, suddenly lifts or drops the ocean floor, it displaces an immense column of water above it. Gravity immediately attempts to restore balance, sending energy outward across the ocean in the form of long, low waves. These waves can travel thousands of kilometers with very little loss of energy. In the deep ocean, tsunamis are difficult to detect. Their wave height may be less than a meter, and their wavelength can stretch over hundreds of kilometers. A ship at sea may pass directly over a tsunami without the crew ever realizing it. But beneath the surface, the wave is moving at astonishing speed, often between 700 and 900 kilometers per hour. The true danger of a tsunami reveals itself near the coast. As the wave enters shallow water, friction with the sea floor slows it down. The energy that once spread across the ocean is compressed, forcing the wave to rise dramatically in height. What was once invisible becomes a towering surge of water capable of flooding far inland. Another critical feature of tsunamis is that they arrive in waves, not singular events. The first wave is not always the largest, and subsequent surges can arrive minutes or even hours later. This characteristic has cost countless lives when survivors assume the danger has passed too soon. Scientifically precise yet terrifyingly unpredictable, tsunamis are among nature's most powerful phenomena, silent travelers of the deep that reveal their strength only at the moment of impact. Tsunamis are not random acts of nature. They are the direct result of immense geological forces constantly shaping the planet beneath our feet. To understand why tsunamis occur, one must look far below the ocean surface, into a world of shifting plates, molten rock, and stored energy released without warning. Earthquakes, the primary trigger, The vast majority of tsunamis are caused by powerful underwater earthquakes, particularly those occurring along subduction zones. These zones exist where one tectonic plate is forced beneath another, locking together for centuries as stress accumulates. Over time, pressure builds to an unimaginable level. When the plates finally slip, the release of energy is sudden and violent. If this movement causes the seafloor to rise or fall vertically, even by a few meters, it can displace billions of tons of seawater above it. The ocean responds instantly, lifting and dropping in a massive, synchronized motion. This vertical displacement is critical. Horizontal motion alone rarely produces a tsunami. The greater the area of the seafloor involved, and the larger the earthquake's magnitude, the more powerful the resulting tsunami. Some of the strongest earthquakes ever recorded, those exceeding magnitude 9.0, have occurred beneath the ocean and generated tsunamis capable of crossing entire ocean basins. Volcanic eruptions. Fire beneath the sea. Volcanic activity can also generate tsunamis, though through multiple mechanisms. Explosive underwater eruptions can rapidly displace water, while the collapse of volcanic structures into the sea can produce massive waves. In some cases, pyroclastic flows, fast-moving clouds of hot gas, ash, and debris, rush down volcanic slopes and slam into the ocean, forcing water outward with devastating power. One of the deadliest tsunamis in recorded history followed the catastrophic eruption of Krakatoa in 1883. The collapse of the volcanic island triggered enormous waves that struck nearby coastlines, killing tens of thousands of people and sending shock waves around the globe. Landslides, sudden shifts of earth and water. Landslides, both underwater and coastal, are another significant tsunami source. These events can be triggered by earthquakes, volcanic eruptions, or gradual geological instability. When large volumes of rock and sediment suddenly plunge into the ocean, they push water aside violently, creating waves that can rise to extreme heights near their source. Unlike earthquake-generated tsunamis, landslide-induced waves tend to be more localized, but can be extraordinarily destructive in nearby regions. Some of the highest tsunami waves ever recorded, exceeding 100 meters, were caused by massive landslides in confined bodies of water. Meteor impacts. Rare but catastrophic. Though extremely rare, the impact of a large meteor or asteroid into the ocean has the potential to generate tsunamis on a global scale. Such an event would displace vast volumes of water almost instantaneously, sending waves racing across multiple oceans. Geological evidence suggests that ancient impacts may have triggered enormous tsunamis, contributing to widespread environmental change and mass extinctions. Each of these geological forces reminds us that tsunamis are not singular events, but outcomes of Earth's continuous evolution. A reminder that the planet is alive, dynamic, and indifferent to human boundaries. The journey of a tsunami begins in darkness, deep beneath the ocean floor where Earth's crust fractures and shifts. In the seconds following a sudden geological disturbance, the ocean above is set into motion, not as a single cresting wave, but as a vast transfer of energy. When the seafloor abruptly rises or falls, it displaces an entire column of seawater. Gravity immediately seeks to restore balance, and the disturbed water begins to oscillate. This oscillation generates a series of long-wavelength waves that radiate outward in all directions, moving across the ocean with remarkable efficiency. In deep water, tsunamis behave unlike ordinary waves. Their energy is distributed throughout the entire depth of the ocean, sometimes reaching several kilometers below the surface. This allows them to travel at incredible speeds, often approaching 800 kilometers per hour, while remaining almost invisible from above. To an observer at sea, a tsunami may appear as nothing more than a gentle rise and fall of the water. As the wave approaches land, the ocean's depth decreases, and the behavior of the tsunami begins to change. Friction with the seafloor slows the wave, causing its wavelength to shorten. The energy that once spread across a vast area is compressed, forcing the wave to grow taller. What was once an imperceptible motion becomes a towering surge. In many cases, the trough of the wave reaches the coast first, causing the ocean to withdraw dramatically. Shorelines recede, harbors empty, and the seafloor is briefly exposed. This unnatural retreat is one of nature's most ominous warnings, yet it has often been misunderstood or ignored. When the tsunami arrives, it does not break like a typical wave. Instead, it surges inland like a fast-moving flood, carrying debris, vehicles, and structures with relentless force. The water can penetrate kilometers inland, depending on coastal shape and elevation. Equally dangerous is the retreat. As the water flows back toward the sea, it drags everything in its path with it, eroding foundations and pulling debris back into the ocean. And this cycle can repeat itself multiple times as additional waves arrive over the course of hours. From a silent disturbance in the deep to overwhelming destruction at the shore, the life cycle of a tsunami is a powerful reminder of how quickly the hidden forces of Earth can rise to the surface. Throughout human history, tsunamis have arrived without warning, leaving behind altered coastlines and rewritten destinies. These waves were not merely natural disasters. They became turning points, moments when entire societies were forced to confront the limits of human control over nature. The Indian Ocean tsunami of 2004. On the morning of December 26, 2004, a magnitude 9.1 earthquake struck off the western coast of Sumatra. It was one of the most powerful earthquakes ever recorded. In seconds, the seafloor ruptured along a fault line stretching more than 1,300 kilometers. The ocean above it responded instantly. The resulting tsunami spread across the Indian Ocean at jetliner speeds. Within minutes, waves struck Indonesia's Aceh province. Hours later, coastlines in Sri Lanka, India, Thailand, and even East Africa were hit. Many with no warning at all. Entire villages vanished. Families were separated forever. By the end, more than 230,000 lives were lost across 14 countries. The disaster revealed a devastating truth. While tsunamis had long been studied in the Pacific, much of the Indian Ocean had no early warning system in place. In response, the world acted. A multinational tsunami warning network was established, marking one of the most significant advances in global disaster preparedness. The Tohoku tsunami of 2011 Japan has lived with tsunamis for centuries. Its coastlines are lined with seawalls, evacuation routes, and warning sirens. Yet on March 11, 2011, even these defenses were tested beyond their limits. A magnitude 9.0 earthquake struck beneath the Pacific Ocean east of Honshu. The tsunami that followed reached heights of over 40 meters in some areas, overwhelming coastal barriers and flooding cities within minutes. Beyond the immediate destruction, the tsunami triggered one of the most serious technological disasters in modern history, the Fukushima Daiichi nuclear accident. Power systems failed, cooling mechanisms shut down, and radioactive material was released into the environment. The event reshaped global energy policy, forcing nations to reconsider the risks associated with nuclear power in geologically active regions. The Krakatoa eruption of 1883. In August 1883, the volcanic island of Krakatoa erupted with a force rarely witnessed in recorded history. The explosion was heard thousands of kilometers away, but it was the ocean that delivered the deadliest blow. The collapse of the volcano generated massive tsunamis that slammed into the coasts of Java and Sumatra. Entire towns were swept away. Over 36,000 people perished, most of them due to the waves. The eruption also altered global climate patterns, dimming sunsets around the world and reminding humanity that local events can have planetary consequences. Ancient and forgotten tsunamis. Long before written history, tsunamis reshaped civilizations. Geological evidence, sand deposits found far inland, reveals that ancient coastal societies were repeatedly destroyed and rebuilt. Oral traditions passed down through generations preserve memories of great waves that came without warning. These forgotten tsunamis remind us that humanity's relationship with the sea has always been one of both dependence and vulnerability. When the water finally retreats, the true scale of a tsunami's impact begins to emerge. The destruction left behind extends far beyond collapsed buildings and flooded streets. It reaches deep into the social, environmental, and economic fabric of affected communities. Human consequences. The most immediate and devastating cost is human life. Tsunamis strike with little warning, giving people minutes or seconds to react. Entire families are often lost together, leaving survivors with profound grief and trauma. Those who live through the disaster face long-term psychological scars. Post-traumatic stress, anxiety, and depression are common, particularly among children. Displacement compounds the suffering, as survivors are forced into temporary shelters, sometimes for years. Cultural heritage is also lost. Historic towns, sacred sites, and centuries-old traditions can disappear in a single day. Environmental impact. Tsunamis dramatically reshape natural environments. Coastlines are eroded. Forests are uprooted. Coral reefs are damaged by debris and sediment. Saltwater intrusion contaminates freshwater supplies and agricultural land, rendering soil infertile for years. Mangrove forests and coastal wetlands, which serve as natural buffers, are often destroyed, ironically increasing vulnerability to future disasters. Economic devastation. The economic cost of tsunamis can reach hundreds of billions of dollars. Ports, roads, power systems, and communication networks are often obliterated. Fishing industries collapse. Tourism vanishes overnight. For developing nations, recovery can take decades. Limited resources, combined with the need to rebuild infrastructure and restore livelihoods, create long-term dependency on international aid. A long road to recovery. Rebuilding after a tsunami is not just about reconstruction, it is about resilience. Communities must decide whether to return, relocate, or adapt. Each choice carries emotional, cultural, and economic weight. The aftermath of a tsunami reminds us that disasters do not end when the water recedes. Their true impact unfolds over years, shaping the future of generations yet to come. For centuries, tsunamis were sudden and inexplicable disasters, striking coastal communities with little more than intuition or folklore as warning. Today, humanity has learned to listen to the ocean, using science and technology to detect the subtle signals that precede these devastating waves. Modern tsunami warning systems begin deep beneath the Earth's surface. Networks of seismic sensors continuously monitor tectonic activity, detecting underwater earthquakes within seconds of their occurrence. When a powerful quake is recorded, scientists analyze its location, depth, and mechanism to determine whether it is capable of generating a tsunami. But earthquakes alone do not tell the full story. To confirm whether a tsunami has actually formed, scientists rely on deep ocean pressure sensors, commonly known as DART buoys, Deep Ocean Assessment and Reporting of Tsunamis. Anchored to the seafloor, these instruments detect tiny changes in water pressure caused by passing tsunami waves. Even a rise of just a few centimeters can be enough to trigger an alert. Once detected, data is transmitted via satellite to tsunami warning centers, where models predict wave height, arrival time, and potential impact zones. Within minutes, warnings can be issued across entire ocean basins, giving coastal populations precious time to evacuate. In addition to offshore detection, coastal tide gauges provide real-time measurements of sea level changes as tsunamis approach land. Satellites further enhance monitoring by tracking sea surface anomalies across vast distances. Despite these advances, technology has its limits. Not all earthquakes generate tsunamis, and false alarms can erode public trust. In regions close to the epicenter, waves may arrive before warnings can be issued. In such cases, Human awareness, recognizing natural signs like strong shaking or sudden sea withdrawal, remains critical. Warning systems do not stop tsunamis. They buy time. And in the face of a force measured in seconds, time is the most valuable resource of all. As long as tectonic plates continue to move, tsunamis will remain an inevitable part of life for coastal societies. The question is no longer whether tsunamis will occur, but how humanity chooses to live with the threat. Preparedness begins with education. Communities that understand tsunami risks are more likely to respond quickly and correctly. Simple knowledge, such as evacuating immediately after strong coastal earthquakes or sudden sea retreat, has saved countless lives. Urban planning plays a crucial role. Evacuation routes, vertical shelters, and clearly marked safe zones can mean the difference between survival and tragedy. In some regions, buildings are designed to allow water to flow through lower levels, reducing structural collapse. Nature itself offers protection. Mangroves, coral reefs, and coastal forests absorb wave energy, reducing the force of incoming water. Preserving and restoring these ecosystems is one of the most effective and sustainable forms of tsunami mitigation. Looking forward, climate change presents new challenges. Rising sea levels mean that future tsunamis may penetrate farther inland, even if wave heights remain unchanged. Increasing coastal populations further amplify risk, placing more people and infrastructure in harm's way. Advances in artificial intelligence, real-time modeling, and satellite observation promise faster and more accurate warnings. Yet technology alone is not enough. Preparedness requires political commitment, international cooperation, and long-term investment. Living with tsunamis demands humility. It requires acknowledging that humanity cannot control the ocean, but can learn to respect it, adapt to it, and coexist with it. The ocean is both cradle and crucible, giving life, shaping landscapes, and connecting distant continents. Its waves carry stories of creation and destruction, of civilizations built and washed away. Among these stories, the tsunami stands as one of nature's most dramatic reminders of power beyond human control. Tsunamis are not monsters. They are messages, manifestations of Earth's restless energy, moving in silence across oceans, revealing their strength only when they meet the shore. They remind us that the world we inhabit is alive, dynamic, and indifferent to our ambitions. Human ingenuity, technology, and preparation can save lives, but they cannot tame the ocean. They can only help us coexist with it. In studying tsunamis, we learn not only about waves, earthquakes, and volcanic eruptions, but also about resilience, awareness, and respect. We learn that survival depends on observation, knowledge, and timely action. We learn that preparation, both practical and psychological, is as vital as any seawall or warning system. As we gaze out over the horizon, it is easy to forget the forces moving beneath the waves. But the ocean never sleeps. It remembers the ancient upheavals and whispers the lessons of survival to those willing to listen. Ultimately, tsunamis teach humanity a profound truth. The Earth is powerful, beautiful, and unpredictable. To live alongside it is to respect its rhythms, to honor its lessons, and to recognize that true strength lies not in domination, but in understanding, vigilance, and humility. The ocean reminds us we are small, yet capable of great foresight, and in that balance lies the key to our coexistence with the world's most formidable forces.